bucka. Ha. You know the deal.
The next thing we're going to talk about in our patterning and algebra unit is called solving simple equations by observation. And before we start this lesson, it's important to note what we're going to be talking about here is solving algebraic equations. And the method that is used in this video is just meant to be an introduction to solving equations. Further down the line, when you get into grade 7 and beyond, you're dealing with equations that are more complex than the ones you're going to see in this video, and there are other methods that you're going to learn to solve equations. But as an introduction, we're going to start by solving equations by what's called observation. And to start, we're going to look at an example. So this is an example of a real-life situation where we have a mathematical problem to solve. So Spencer is in a job and he's getting paid to play video games, and he gives his opinion on that, and he gets paid $8 per hour to do that job. And the company that he works for keeps track of the hours and then sends his check. So at the end of 1 week, he gets his check for $72, and he wants to know, well, how many hours did he actually work? Now, there are a variety of ways that you could get the answer to this question, but one of those ways is using algebra. And again, this is a fairly simple, straightforward example. As an introduction, we're starting with simple, straightforward examples, but as you get further down the line, you get more complex problems to work on, where algebra is really a very useful tool in solving complex problems. So we're going to look at how to use algebra to solve a problem like this. And to start here, we're going to start by writing an equation. And if you watch the Introduction to Algebra video, you should have some idea what the equation would be here. And when we're starting to write an equation, well, we start with the pieces of information that change in our situation so that we can assign variables to those pieces of information. And in this situation, the two pieces of information that change is how many hours Spencer works and the total pay that he's going to get. That can change from week to week. Now, we can choose any letters to represent those two pieces of information. I purposely choose X and Y, and if you watched the video on ordered pairs and graphing, you would have some idea as to why I chose those two variables in particular. But again, you could call the number of hours H and the total pay T if you wanted to, but here I'm choosing X to represent the number of hours and Y to represent the total pay for those two pieces of information that change here. So the next thing we're going to do is write our equation. Well, I'm not going to go through the whole lesson in terms of how we would write an equation. That's in the Introduction to Algebra video, but you would look at this situation and you know that to get the total pay, we would have to multiply 8 times the number of hours. So to write that as an equation, we would have y equals 8x. And just saying that in English, remember y represents the total pay. So if I'm going to say this math sentence as an English sentence, I would say the total pay is 8, and then the operation that we have here between the 8 and the x is times, so 8 times the number of hours, because x represents the number of hours. And that's how we would calculate Spencer's total pay using an equation. Well, now we're going to use this equation to solve the problem that we have here. And the problem that we have here is we know how much the total pay is for this particular week. The piece of information that we don't know is, well, how many hours did he work? So what we're going to do is we're going to take that value, his total pay, and substitute it into our equation. And again, y represents the total pay. So instead of writing y, I'm going to write 72, because we know for this week he made $72 in total. What we don't know is how many hours he worked. So that's our value of x here. So when we're trying to solve an equation that looks like this, well, we want to know what is the value of x. And we can look at this equation and it's saying, well, 8 times some number that we don't know is 72. Or 72 is 8 times some number that we don't know. So we have to try to figure out what that number is. And solving by observation means we just look at this simple example of an algebraic equation and we ask ourselves, well, what number times 8 would be 72? And hopefully we know, well, we have to divide to try to figure out what that is, and we have to divide 72 divided by 8. And 72 divided by 8 is 9. So that means that the number of hours must be 9, or 9 is the number of hours. And we can check to see if our answer is right by substituting it back into the original equation. So what we're saying is he made $72. If he worked 9 hours, he's getting paid $8 an hour, so we would take 8 and multiply it times 9. And when we solve what's on the right hand side of the equation, 8 times 9 is 72. And 72 is the same as 72. So this is a way to check to see if we have the correct answer by substituting the answer we got back into the original equation. And if we end up with a statement that's true, then we know we got the right answer. So that's the beauty of solving algebraic equations, is you can always check your answer by substituting the answer that you get back into the original equation. So the answer to the question would be, he worked 9 hours. So for the first example there, I looked at a real life situation, made it into an equation, and then solved the problem using the equation. For the rest of the examples, we're just going to look at equations. These equations would come from real life situations, but just so we can see a variety of these types of equations and how to solve them, I'm not going to make up the real life situations. Now we're just going to look at the equations and solve them by observation. So here our simple algebraic equation is x plus 5 equals 7. In other words, some number plus 5 equals 7. We can look at this and hopefully figure out, well, that number has to be a certain value. To figure out what that value is, what we're going to do is we're going to subtract 5 from 7. And by doing that, we can figure out that x must be equal to 2. And the reason for that is if we take our answer and put it back into the original equation, instead of writing x, I'm going to write a 2. The rest of the equation stays exactly the same. And we have a true statement there, where 7 equals 7. So since this is a true statement, after we substituted our answer back into the original equation, so instead of writing x, I wrote 2, that means our answer must be right. Now let's look at the same example, but suppose we were trying to rush through this type of a question, and we didn't think very carefully about what number added to 5 would have to equal 7, and we answered incorrectly. So we answered x equals 3 by mistake. So now what we're going to see is if we take that answer and substitute it back into the original equation, so instead of writing x, I'm going to write 3, because that's what I think the answer is. When I go to simplify that, so I have 3 plus 5 equals 7, because again, instead of writing x, I wrote 3, because that's what I think the answer to this equation is. Well, 3 plus 5, when we add 3 plus 5, we get 8 on the left-hand side of the equal sign. And on the right-hand side of the equal sign, we have 7. Well, this is not a true statement. And since this is not a true statement, we know that this can't be correct because this can't be a true statement. So again, the beauty of these types of algebraic equations, you can always check your answer, and then if it doesn't work out, if the left side isn't the same as the right side, you know you've done something wrong. So you have to go back and check your math. And if you go back and check your math, you go, whoops, it's not 3. 2 plus 5 is 7. So x has to be equal to 2. Which we already checked, so we know that that is the correct answer. So here's another example of a simple equation that we're going to solve by looking at the equation. So what we're saying here is some number minus 3, or 3 subtracted from a number, is 7. And we have to try to figure out what that number is. And hopefully we realize, well, to figure that out, we have to add 3 to 7. And when we do that, we know that x equals 10. We check our answer by substituting our answer back into the original equation. 10 minus 3 is 7, so we would get 7 equals 7, which is a true statement. So we know we have the right answer. So in this example, we have 4 times y is 12, or 4 times some number that we don't know yet is 12. We need to try to figure out what that number is. We know we're multiplying that number times 4 to get 12, so to figure out what that number is, we have to divide 12 divided by 4, and 12 divided by 4 would be 3. If we take that and substitute it back into the original equation, so instead of writing a y, I would write a 3. Now, multiplication, I would probably want to write using brackets rather than that symbol x for times. And 4 times 3 is 12, so we do get the true statement that 12 equals 12. So again, we know we have the correct answer. So in this example of our simple algebraic equation, we've got a number we don't know, which is called q in this case, and it's written as a fraction here over 5, and if you watch the video on Introduction to Algebra, you would know that in algebra we typically don't use what we would normally use for the division symbol, which looks something like that. We write division as a fraction. So this is some number q divided by 5 is equal to 7. So, and we need to figure out what that number q is. So we would figure that out by multiplying 7 times 5. And we would know then that q has to be equal to 35. And again, if I take the answer and substitute it back into the original equation, we get 35 divided by 5. I'll write it as a fraction because it's written that way in the equation, is equal to 7. 35 divided by 5 is 7, so we get the statement, the true statement, which is 7 equals 7. So to finish off our lesson on solving algebraic equations by observation, I'm going to ask you to answer a few questions here. So for each one of these questions, you're just being asked to find the value of the unknown. So whatever the value of the letter is. Now if you take a look at the very last question there, question 5, there's two pieces of that question. So what we're told here, first of all, is 3r equals 6. So in other words, 3 times some number equals 6. And then the value of r plus some other value, s, equals 7. The final question is, what is the value of s? If you're able to answer those 5 questions, congratulations, you now have a firm understanding of solving simple algebraic equations by observation.